So dear students, in today's class, we shall discuss about the following topics. One is the instruments which are required for engineering graphics. Then we will be learning about type of lines. Then it is about dimensioning. So we will be learning about some three topics today. One is the instruments which are required for drawing, then type of lines, then dimensioning. So we shall start with the instruments which are required. Okay, so first this is what you call as a clutch pencil. Okay, this is a clutch pencil. So this is actually a 0.5 mm clutch pencil. 0.5 is the dimension of the corresponding lead that is inserted into this particular clutch pencil. Okay, so you'll be calling it as a click pencil also. So you can insert the lead to this particular side. So when you press the bottommost, the topmost side of this pencil, you'll be getting the lead will be projected outwards. Okay, so 0.5 mm plus pencil. Then you get a scale, okay, or a ruler. Okay, preferably some 30 mm or 30 centimeter or 15 centimeter is enough. And if possible, you get a roller scale also. This is what we mean by a roller scale. The roller scale will be helping us to draw parallel lines in a more easier way. So if possible, so whenever you are out of the lockdown, you may purchase this. Then you have to have a compass with a pencil. So if you are not having this sort of a pencil also, that is fine. You can use an ordinary wooden pencil. So if you are having this pencil, it will be more fine. So this is also another clutch pencil. Then you have to have a protractor, 180-degree protractor. So then if possible, you buy a pro circle also. So this is what we mean by a pro circle. Okay. Now we shall move on to the type of lines. So as I have mentioned in the previous class, engineering graphics is the language of engineers. So for any language, we will be having alphabets. In case of engineering graphics, lines are the alphabets. So there are many type of lines. So each of these lines are named with respect to the English alphabets. Type A lines, type B lines, type C lines. So from these type of lines, we shall learn about some 4 type of lines and their uses initially. Okay, so first type of line is type A line. It is known as continuous thick line. Okay, type A lines, they are known as continuous thick lines. They are usually used for drawing visible outlines and visible edges. Okay, now we shall see how to draw a continuous thick line. So after taking your scale, using your pencil, you can draw, let us draw a continuous thick line of some 10 centimeter length. Okay, so you have to apply sufficient pressure on the pencil so that the line is sufficiently thick and dark. Okay, so this is a continuous thick line. So we shall draw this line once again, a 10 centimeter line. You apply sufficient pressure on the pencil so that the line is sufficiently dark and thick. Okay, so this is a continuous thick line. So the thickness of the line must be uniform throughout, and the darkness of the line also must be uniform throughout. Okay, so here you can see another line. So preferably the thickness and darkness of the lines must be uniform throughout the length of the line. So these type of lines are used for drawing visible outlines and visible edges. So we shall see later what we mean by a visible outline and a visible edge. Okay, so next type of lines are known as continuous thin lines. So the similarity between type A line and type B line. So this is type B line. Both are continuous in nature. One is thick line, another one is thin line. Okay, so how to draw a continuous thin line? So let us draw a continuous thin line of 10 centimeter length. So you can use your scale. So you don't apply as much as pressure you have applied, you have applied more pressure for drawing this continuous thick line. So you don't apply much pressure when you are drawing this type of lines. You just draw it very casually. Don't apply so much of pressure. Okay, so a line of 10 mm length. Okay, so when you notice this line and this line, both are drawn with the same 0.5 mm plus pencil. So in this particular pencil, actually I have inserted the lead, which is having a specification HB. Okay, so this is 0.5 mm HB lead. I am using this lead. So for drawing both of these lines, actually I have used the same pencil and same lead, but there is a drastic difference between these two lines. This line seems to be thin and less in its darkness. So what is the difference? Why these two lines became different, although I have drawn it with the same pencil? The only difference is how much pressure you are applying. Okay, so this is continuous thin line. We shall draw it once again. So we shall draw a continuous thin line of 10 centimeter length. So you apply less amount of pressure, or you need not apply pressure. You just casually draw this line without applying pressure. So again you got a continuous thin line. So please note the difference between the two lines. One is continuous thick, another one is continuous thin. So this is lesser in its darkness and thickness. This is more in its darkness and thickness. We are drawing the two lines with the same pencil and the same lead, but they are having a difference. The difference is in the application of pressure. Okay, so continuous thin lines, they are used for drawing dimension lines, projection lines, leader lines, and hatching lines. Okay, so these are the uses of continuous thin lines. So we shall see later what we mean by a dimension line, what we mean by a projection line, what we mean by a leader line, and what we mean by a hatching line. Okay, now we shall see the next type of line. So type E lines, they are known as dashed thick lines. Okay, dashed thick lines, they are mainly used for drawing hidden outlines and hidden edges. So first we shall see how to draw this dashed thick line. Okay, dashed thick line. So we shall draw a dashed thick line which is having a length of some 10 mm. Okay, so this is dashed thick line. So we shall draw a dashed thick line of 10 mm length. So I'm using a pencil, and you apply sufficient amount of pressure on this pencil. Okay, so line, another line. So I'm putting small gaps. I am not drawing it as a continuous line. A small gap is there between the lines, is it? Okay, approximately it is 10 mm. So here you can see gap between these lines. Okay, so each of these small lines are almost same in their length, and the gap between these lines are also the same. Okay, so when you draw a dashed thick line, it will be something similar to this. Each of these lines are having the same length, and the gap between these lines are also the same. I shall draw another dashed thick line. Please observe how it is done. So this is another dashed thick line. Okay, so here the again each of these small lines are having the they are having the same length, and the gap between these lines are also almost the same. So this is also a dashed thick line, and this is also a dashed thick line. The length of the small line, it varies from diagram. It must be proportionate to the diagram that you are drawing. We shall learn it in detail later. Okay, so they are used for drawing hidden outlines and hidden edges. Now we shall learn type G lines. Type G lines, they are known as chain thin lines. Okay, they are known as chain thin lines. Okay, So they are usually used for drawing center lines and lines of symmetry. Type G lines, they are used for drawing center lines and lines of symmetry. So how to draw a chain line? Let us observe it. Okay, so I have applied a small pressure when I am drawing this particular line. Okay, so here you have got a big line, a small line, another big line, a small line, again a big line and a small line. So here we have got gap between these two lines also. So this line and this line, they must be almost of the same length. Again this one, this one, this one and this one. All these big lines must be almost of the same length, and all these small lines also must be almost of the same length. Okay, and the gap between these lines must be also the same throughout. So these type of line, this type of line, they are known as chain thin line. We shall draw it once again. Okay, so here I have drawn another chain line. So what is the difference between these two chain lines? Here the length of the bigger line I have made slightly shorter than the previous one. So this is another chain thin line. So the length of these lines, it depends upon the size of the diagram that you are drawing. If you are drawing a bigger diagram, you use a bigger chain line. If you are drawing a smaller diagram, you use a smaller chain line. Okay, so the gap between these lines must be the same. This line, this one, and this one, almost they must be of the same length. And this small line, this one, and this one also must be of the same length. Okay, so here also I have drawn two dash thick lines. So depending upon the size of the diagram, if the diagram is bigger, you can use this line of this much length, and if the diagram is smaller, you can use a smaller dash thick line. Smaller means the lines, these small lines will be shorter in their length. So this is about the different type of lines. We have got many other type of lines also, but for the time being, this is enough. And as and when required, I shall teach the remaining type of lines if at all it is required. Okay, now we shall go to the dimensioning process. So whenever we are drawing any sort of diagram, you need to dimension it. You need to mark the dimensions. Okay, then only the idea of that particular diagram will be clear. So here I have drawn a diagram. So if you notice, here we have got some thickness, here we have got another thickness. So it is somewhat in a stepped format. Okay, so we shall draw the we shall do the dimensioning process for this particular diagram. So both these diagrams are one and the same. We shall dimension this diagram first. So this thickness, it is approximately 1 centimeter or 10 mm. Usually in engineering drawing, we will be marking the dimension in terms of mm, not in terms of centimeter. Usually we will be marking it in terms of mm. So here, this line or this thickness, this one is 10 mm. So in order to mark this dimension as 10 mm, I am extending a small thin line from this end, and this line is known as a projection line. Okay, this one is known as a projection line. I am drawing a thin line, continuous thin line. This is a projection line. Again, I am drawing another thin line. This is also a projection line. Okay, so this distance is 10 mm. This distance is 10 mm. So we shall mark the dimension here. So I'm drawing two projection lines again and marking an arrowhead here. The gap between these two arrows are 10 mm. 10 mm. Okay. So this 10 is known as the dimensional value. Now this length, we shall just measure it. This length is approximately 25 mm. 25 mm or 2.5 centimeters. So we shall draw another projection line from this end, a thin line, and we shall draw a dimension line also. So this is known as a dimension line. So these two are known as projection lines. This one is known as a dimension line. I am drawing an arrowhead also here. So the size of this arrowhead must be proportionate to the diagram that you are drawing. So this is 25. When you are writing the dimensional value must be almost to the center of the dimension line, and it must not touch the dimension line. It must be almost to the center of the dimension line, and it must not touch the dimension line. Okay, so this is 25. So this line is known as a dimension line. This is the dimensional value. Okay, now we shall see what is this dimension. This is approximately 30 mm. Okay, 30 mm. I'm extending another projection line. So this is a projection line, a thin line, a chain thin line. Okay, then I am drawing a dimension line. Again, it is a chain thin line. And to the end of this dimension line, I am drawing two arrowheads. So the size of this particular arrowhead, it must be in the ratio 1:3. If this height is 1, this length must be 3. Okay, it must be in the ratio 1:3. It is not necessary that this is 1 mm and this is 3 mm. It is not 1 mm by 3 mm. Always the ratio must be 1:3. It may be sometimes 2 to 6. It may be 1.5 to 4.5. That is, the height is 1.5 mm. The length is 4.5 mm. So what you have to take care is the ratio must be height to length ratio must be 1:3. The actual dimension of this arrowhead varies from diagram to diagram depending upon the size of the diagram. So one more arrowhead here. So the dimension is 30 mm. So 30 is known as the dimensional value. It must not touch the dimension line, and the dimensional value must be almost to the center of the dimension line. Sorry. So here this distance, this is approximately 40 mm. So we shall draw one more projection line and one more dimension line here. Sorry, the darkness must be somewhat less. Two arrowheads. So this is 40. So 10, 25, 30 and 40. So when you are writing these type of numerals here, this height, it can be approximately some 3 to 5 mm. Height of this one and this one, it may be approximately 3 to 5 mm. So I have dimensioned this diagram. This type of dimensioning process is known as, or method is known as chain dimensioning. So here this is 10, next one is 25, next one is 30 and next one is 40. So this is known as chain dimensioning. Chain dimensioning. Now we shall dimension this diagram. Okay, we shall dimension this diagram. So both are one and the same. Now we shall dimension this diagram. So this dimension is 10 mm. We shall mark it here. I am drawing two projection lines, continuous thin lines, and a dimension line here, two arrowheads. So this is 10 mm. Now this dimension is 25, is it? I am drawing a projection line here. Another projection line here. So this is 25. The next one is 30. So this is 30 and this is 25. So totally I am going to mark it as 25 plus 30, which is 55. 55. So this is totally 55. Dimensional value must not touch the dimension line. The next one is 40. Next one is 40. So this is 40. We shall mark it together. 40 plus 30 plus 25. So 40 here it is 55. 55 plus 40 it is 95. So 95. Just a minute. The dimensional value when you are writing it must not touch the dimension line. So we have dimensioned two diagrams. This diagram and this diagram are the same, but the way in which I have dimensioned it is different. So this type of dimensioning method, it is known as chain dimensioning, and this type of dimensioning method, it is known as parallel dimensioning. So here it is 25. Parallel to this dimension line, I have drawn one more 55, again one more 95. Okay, so totally this is 25. Again you are adding 30. 25 plus 30 it is 55. Again 55 plus 40 it is 95. So this is known as parallel dimensioning and this is known as chain dimensioning. So when you are drawing parallel dimension lines, each of these dimension line must be having a necessary distance. A minimum of some 8 to 10 mm is enough. So between these two lines at least some 10 mm distance is required. Between these two at least 10 mm is required. Okay, and from the diagram also some 8 to 10 mm preferably it is required. You must not mark this dimension very close to the diagram. And in this diagram you can see a chain line also here. Okay, this chain line. So what is the purpose of a chain thin line? It is used for drawing center lines and lines of symmetry. So this is actually the center line of this diagram, or else you can call it as a line of symmetry. What do you mean by a line of symmetry? A line of symmetry means towards the top side and towards the bottom side of this chain line, this diagram is symmetry. Okay, so that is what we mean by a chain line or line of symmetry. That is the purpose of a chain thin line. So you please note the darkness difference and thickness difference of the various lines also. So the darkest line in this diagram is the this lines is this outline. Okay, so it is drawn using continuous thick lines. These are projection lines. They are not drawn using continuous thin lines. Dimension line is also drawn as a continuous thin line. So this is known as the dimensional value. So the dimensional value must be to the center of the dimension line and must not touch the dimension line also. Okay, now we shall see the dimensioning of another diagram. So you have got another diagram here. Now let us mark the dimension of this diagram. So here you can see an inclination here. So if you want to mark the dimension of this inclined line here, you have to use two projection lines which are starting from the ends of this inclined line, and it must be perpendicular to this inclined line. So let us see how it is drawn. So this line, approximately it is having a distance of some 40 mm. 40 mm is the distance of this line or dimension of this line. So I am drawing a projection line perpendicular to this 40 mm line. From this 40 mm line I am drawing a perpendicular line. From here also I am drawing another perpendicular line. Okay, so from here another perpendicular line. So these two are projection lines which are drawn perpendicular to this inclined line, and I am intending to show the dimension of this line, is it? So just parallel to this line I am drawing the dimension line. Dimension line is also a chain thin line. To the end of this chain thin line you have to draw two arrowheads. So this is 40. So this 40 must be parallel to this dimension line. It must not touch the dimension line also. So it must be parallel, written parallel to this dimension line. Okay. So we shall measure what is this dimension. This one is approximately 60. Okay. So I am drawing two projection lines here. Perpendicular to the 60 mm line, I am drawing two projection lines, and I am drawing a dimension line here. And to the end of this dimension line, I am drawing two arrowheads. So please remember that the arrowheads are in the ratio 1:3. You have to mark the dimensional value to the center of the dimension line, and the dimensional value must not touch the dimension. It is not exactly to the center. I shall do it once again, just a minute. Go to the center, the dimensional value. We shall measure what is the dimension of this line. This one is approximately some 32 mm. 32 mm. So I am drawing two projection lines, thin lines, and a dimension line connecting these two projection lines, and two arrows. The dimensional value is 32. So here I have got an inclined dimension line. Here I have got another vertical dimension line. Here I have got a horizontal dimension line. So along all these dimension lines I have written 40, 32, 60, etc. So here I have drawn a set of dimension lines, is it? So you can consider these two dimension lines as vertical dimension line. So these two are some horizontal dimension lines, and this one, this one, and this one, and this one are some sort of inclined dimension line. So how to write the dimensional value on these dimension lines? There are some particular rules for it. Okay, so in case of these type of dimension lines, these are vertical dimension lines. They are vertical, is it? So you can write the dimensional value to the left hand side of this dimension line. Okay, you can write the dimensional value to the left hand side of this dimension line, and on all the other lines and or sorry and on all the other lines, the dimensional value must be written in such a way that when you are observing from this direction, the dimensional value must be on top of the dimension line. Okay, so here this is an inclined dimension line. The dimensional value is on top of the dimension line. Here it is a horizontal dimension line. The dimensional value is on top of the dimension line. Here it is again an inclined dimension line, but when you are observing from this direction, the dimensional value, which is 30, is above the dimension line. The same is applicable to these three cases also. So when you are observing in this direction, the dimensional value must be above the dimension line. For vertical dimension lines, when you are observing in this direction from the right hand side, the dimensional value must be above the dimension line. You are observing it from this direction, so the dimensional value must be above the dimension line. Okay, or on for vertical dimension line, you can write it on the left hand side. So this is regarding the placement of the dimensional value on the dimension line. Again, we shall dimension some more diagrams. So here I have got two circles. So I have drawn two chain lines here in order to mention that this. So if when you consider this chain line with respect to this chain line, the left hand side and right hand side of this circle is symmetric. With respect to this chain line, again the left hand side and with respect to this chain line, the top side and bottom side of this circle is also symmetric. So that is the meaning of this chain line. Chain lines are used as center lines or lines of symmetry. So here I have got two circles, both are having the same dimension. We shall see what is the dimension of it. It is approximately 70. So we shall mark the dimension here. So for a circle, usually we will be marking the dimension in terms of diameter. Okay, in terms of diameter. So the diameter is 70 mm or 7 centimeters. So we shall see how it is done. So from this extreme, you draw a projection line, a thin line. From this extreme also, you draw another thin line. Now you draw a dimension line connecting these two projection lines. Then you can draw two arrowheads. And to the center of this dimension line, you can mark 570. That means 5 stands for diameter. 5 stands for diameter. 570 means the diameter of this particular circle is 70. Okay, we shall mark the dimension of this circle also in some other way. Okay, so this is a projection line, this is a projection line, and this is a dimension line. This is a continuous thick line. Okay, and we shall mark the dimension of this circle. This line, it is known as a leader line. This line is known as a leader line. So the diameter of this circle is 70. So again I am marking here 570. Here the leader line is somewhat extended beyond the 70. You can just rub it off. So this much length is enough. So this line is known as a leader line. So this is also drawn using type B line, continuous thin line. So we have learned about the various uses of a continuous thin line. So what are they? They are used for dimension line. So this is a dimension line. Excuse me. Projection line. So this is a projection line. Leader line. So this is a leader line. So we shall see hatching lines later. So here we have got some arcs, is it? Here we are having an arc, here also we are having an arc, here also we have got another arc. So now we shall see how to mark the dimension of these arcs. Okay, so the dimension of this arc, it is approximately 15 mm. Okay, let us see how we shall mark. So this is the center of this arc. I'm drawing a dimension line here. So this dimension line is starting from this center. So here this is radius of this, sorry, so I'm drawing a dimension line here. The radius of this arc is 15 mm, so we shall mark it here. R15 means the radius of this arc is 15. And we shall mark the dimension for this arc also. Here also the radius is 15. We shall mark it in a different way. So here also this is R15. R15 means radius is 15. So here we have got another arc. So the radius of this arc is also 15. We shall mark it here. R15. So we shall do the dimensioning of one more diagram. So here we have got a stepped diagram. Here we have got a stepped diagram, is it? So in this case, we shall measure what is this dimension. This dimension is approximately 100 mm or 10 centimeters. We shall mark it. You draw two projection lines. Thin lines. Then you draw a dimension line here. Mark two arrowheads on either sides. So to the center of this dimension line, you have to mark it as 100 mm. Okay. In case of drawing, usually we will be writing the dimension in terms of mm. So now we shall mark the dimension of this side. So for this side, let us check what is the dimension. So the dimension is approximately 40 mm. So I am drawing a projection line from this point. Another projection line from this point. So when you're drawing the dimension line, you have to make sure that we have got some extension of the projection line beyond this dimension line. There must be some small extension here. So you can mark the arrowhead. So this is 40. So next is this one. So this is approximately 30. I'm drawing a projection line. One more dimension line. Arrowhead. this is 30. Now we shall mark the dimension of these two steps. Okay, maybe this one also we shall mark. So what is this dimension? This is again 30. One more dimension line. You can just rub the rest of the projection line. Here also it is 30. We shall mark the dimension of this thickness and this thickness. So what is the dimension of this one? This is 30. I'm drawing two dimension lines. Sorry, two projection lines. A dimension line. So the dimension of this one, it is again 30. So this is also 30. Okay, so this total length, let us measure it. It is approximately 140 mm, 140 or 14 centimeters. We shall do two dimension projection lines. So the dimension line must be parallel to the side of this particular side. So the dimension line must be parallel to this line. Okay, we are drawing it parallel to this line. So this is 140. So this is how we will be dimensioning this diagram. Now we shall mark the angle between these two lines. So the angle between these two lines, so let us measure what is the angle between these two lines. It is 60 degrees. So how to mark it? So for this case, for this purpose, I am using a pro circle. So between these two lines, I am drawing another dimension line. Okay, so this is some sort of an arc, a thin arc. I am drawing two arrowheads on either sides. Again in the ratio 1:3. So the angle is 60, is it? So 60 degrees. 60 degrees. So this is regarding the type of lines and dimensioning process. So thank you all.